Hi, in this video, we are going to see an end-to-end text classification pipeline. So when I say end-to-end, what we are going to do is we are going to take a text corpus. We are going to set up our typical NLP pipeline like text cleaning, lemmatization or stemming, and then we are going to convert that into a vectorized format so that our model can understand. Later we are going to take that particular vectorized output and do our model selection. We typically don't know which model might work better. Is it Naive Bayes or SVM or GBM or XGBoost? So I'm going to show an easy way of selecting the model. And once the model is selected, we are going to take the best model out that we are going to use and fine tune it further. Basically, the data set that I'm going to show is pretty imbalanced. I'm going to show how you can handle imbalanced classes with that model that is the best model out of the model selection process. So let's get started. I'm going to use multiple packages so that we can speed up our hypothesis cycle and the model development cycle. I'm going to install H2O over here, which is just for model selection. And I'm going to use scikit-learn for real model development. So in order to install H2O, I also need Java runtime environment because H2O works on Java. So I'm installing Java runtime environment. In case if you already have a system with Java, you can ignore this step. And I'm doing an install of H2O. I've done these two steps and then importing a set of packages. I'm importing pandas for loading your data and wrangling your data. Then I have like TF-IDF vectorizer to take your text data and convert into a vector representation that your model can understand. I'm also going to talk about like sparse vector and dense vector because TF-IDF works as a sparse vector, but there are even efficient techniques that we'll see in the later video like dense vector. I'm going to talk about it. I'm going to use matplotlib for visualization, then the typical NumPy, regex package, NLTK package, like model selection, H2O, and I'm going to use H2O AutoML for model selection. So I run this as well. The very first thing I'm going to do is I'm going to initialize the H2O cluster. So when I call H2O.init, what will happen is the H2O cluster will get initialized, and based on that you can start developing your model. So it's telling that H2O is up and running, and based on this I can go and do my model there. But before that, like let's focus on our NLP pipeline. So I'm going to download the one of the NLP corpus punct, which is used for sentence tokenizer. I'm downloading it. I'm going to read my data. I'm going to use the banking consumer complaints data set. The consumer complaints data set is available in my GitHub repo. This is kind of an subset that I have created from the CFPB website. CFPB website has a pretty huge corpus. It is Consumer Financial Protection Board. So any customer who are not happy with their bank, go and complain to CFPB. And CFPB is a governing authority where bank has to go and solve the customer problem and close the issue, right? So what I'm going to do is I'm going to download the data. The data is in zip format. So I'm telling like basically here the compression is zip and the separator is kind of comma separated, right? So that's what I'm doing. So when I say compression equals to zip, it will automatically get uncompressed and show the data basically in a tabular format. So you can also download and unzip it yourself. So if you see over here, I have 57, 453 rows and 18 columns. There are a lot of columns in the data set, but what we basically will be working on is very few columns. So I'm going to take the consumer complaint narrative, which is nothing but the text data of the customer complaint. I'm also going to take the product type. This is what I'm going to classifying based on the incoming complaint. Can I categorize it whether it's a vehicle or loan lease or a debt collection? So that will make my kind of solving the issue easy because I can route it to an agent who can answer it better, or write into an or route it to a representative when I know it's vehicle loan. Maybe somebody with vehicle loan experience may be able to close the customer query faster, right? That's what I'm going to do. I am also like picking one other column company, but that I'm not going to use in my final model. Now, what I'm going to do is I'm going to check the target distribution. So I'm taking the product, which is my target column, which I showed you, debt collection, vehicle loan. I'm doing a value count just to see how the data distribution is. So if you see over here, most of my data is around debt collection and credit card or prepaid card, but the others are pretty less, and student loan and vehicle loan is very less. So it's a highly imbalanced data set, right? So we will also look at how to handle this imbalanced data set during the modeling process. I can also do a plot of the distribution. So rather than checking it, so you can see over here based on the plot, again you can see a bar chart, and these two are the lowest category, the student loan and vehicle loan, and you can see how imbalanced the data is. Similarly, I can do the value count for company, like which companies has the most complaint, right? So these are a banking institution. So you can see like basically Citibank and Capital One and Bank of America and JP Morgan and Wells Fargo are the major complaint. And there are like small banks with like pretty low complaints, right? Now what I'm going to do is from this particular data frame, I'm going to select only the consumer complaints narrative, product and company, these three columns. There are 18 columns. I'm going to ignore the other columns. And I'm going to rename the consumer complaint narrative. The column name is very big, to just complaint. So that's why I'm telling you rename, and the column just complaints, and I'm assigning it to a new data frame, complaints DF. So once this is done, let me again print it. And basically now you will see only 3 columns in the output. So now I have a better data set to manage and play around, right? Now this target column, if you see the product column that I said, is nothing but an more like a string value. And for model to work, I need to have it as an kind of an integer or factor value. So for that, what I'm doing is I'm manually defining a dictionary. I'm telling if the target is debt collection, make it 0. If it is credit card prepaid, make it 1, mortgage 2. Like that, I'm just giving a dictionary object over here. And what I'm doing is I'm creating a new column called target in my data frame. And then I am taking the product column, which is nothing but this debt collection and all. I'm calling a map function of this dictionary. So what it will do is it will take the product column. It will go and check the dictionary. If it is debt collection, it will assign 0. If it's credit card prepaid, it will assign 1. So that's what I am doing in this case. Let me run this target, and let me run the complaint as well and the next complaints as well. So now I have one more column which has the numeric representation of the target column. Like you can see debt collection is 0, debt collection checking or savings account is 3 based on the dictionary object I have mapped it. You can also run as factor, which is easy, but better like for us to control it when we have a lot of categories, right? Then I'm going to like do an split of this particular data frame. I'm doing in a 80-20 ratio. So 80 is my training frame and 20 is my test frame. Now I'm going to start the typical NLP pipeline. So the very first thing I'm going to do is I'm going to do stemming. Now either you can use the Potter stemmer, which comes inbuilt. All right, let me run the next 3 steps, as it's going to take time, and then maybe I will like kind of to walk through each of it. So let me run till the TF-IDF vector, and let me kind of come back to it. Okay. So now if you see the first thing I'm doing is I'm setting the stemming pipeline. In this case, what I'm doing is I'm using like snowball stemmer. I can use also the Potter stemmer, but snowball stemmer, what I'm seeing is better in the NLTK library compared to the Potter stemmer, right? Then I am setting what I'm doing from this snowball stemmer. I am downloading all the stop words, and this I'm sorry, like I'm then initializing the stop word. So first I have the stemming, then I have the stop word. So I'm also downloading the stop words, and then I'm assigning all the stop words that are there in the stop word corpus to a stop word variable. So when my text comes in, I want to make sure I remove my stop words and I stem my text. So these are 2 things I'm doing. Then I'm creating a function. This function, what I'm going to do is I am taking all the input text, like say I'm using a TF-IDF vectorizer, right? When I pass the data to a TF vectorizer, it will do a direct continuous sentence. Now from the sentence, what I need to do, I do tokenize it. So that's why this function is. So I'm creating a tokenizing function. I'm taking each word from the incoming text that I pass, and I'm going to show you how to pass the text. I am going to take each word from the text. I'm going to check if the word is greater than 3, or if the word, I'm just doing some data cleaning here, right? So basically, if you see my text on the top, which I add this values like XXXXXXXX. These are nothing but encrypted data. Wherever there is sensitive data, the complaints website has encrypted it. So I want to remove all these values and check at least my word is greater than 2. And also, like I'm going to like kind of check if there's a digit word or something like that. I want to kind of strip it further. Right, so these are the cleaning step I'm doing. I'm taking each and every word. From each and every word, what I'm doing is I'm doing a lower. So I'm calling the method so that I can work on the lower representation, so that my uppercase letter and lowercase letter are not double counted. And then I'm calling the stemming function. And in the stemming function, what I'm telling is if that item is not in stop word that I created on the top, right? Then do the stemming. Otherwise, just ignore that word. So it's going to do a check if it's a stop word. If it's a stop word, it's going to just directly return the previous line. Otherwise, it's going to kind of go and do a stemming of it. So all these things I'm doing in this tokenized method. Now, if you don't want to do it, that's an easy way also. In the TF-IDF vectorizer that we have created, what I can do is in the tokenizer, I have given this function tokenize. You can just leave it. It will do a default tokenizer in that case. But at that time, you don't have flexibility to handle it. So I want more flexibility to handle it. That's why I'm creating my own function. Right, and then I'm telling stop word equal to none because I have already taken care of the stop word. You can also use the internal stop word if required. And what I'm telling is I'm telling my max date, like max document frequency. So only count the words which are there at least in the 75% of the document. If the more than that, then ignore it. Why do I do that? Because I want to remove common words, right? If a word appears in all the document, that means it's a very common word, so I don't want to use it. And I'm telling take only the max 1,000 features out of it. Now this can be controlled. You can say max 10,000 or 20,000. In TF-IDF, it creates a sparse vector, and the more you select, it's better. I will show you what is the sparse vector, and I'm telling lowercase equal to false as I have done the lowercase myself, but you can give it true if you want. And I'm telling n-gram is 1 to 2. So basically a number of n-grams to select, either 1 or 2 maximum. And I am calling this vectorizer tf.fit transform and passing my training data frame over here. In the training data frame, it's going to learn, it's going to create that particular vocabulary, and also it's going to transform because I'm calling a fit transform. Now let me print the vector. Once I print the vector, you can see how the output looks like. Because I have given 1,000 columns, each row will have 1,000 array values, and if you see, most of the value is 0. The reason is only words where the occurrence is there to set to 1. In this case, if you see here, it has set, right, there's no entire 1,000, it has just give dot dot dot. But that's what is a sparse representation, and that's why TF-IDF, if you see sparse representation, you create a lot of confusion because you need to have huge vector size to handle. And there's a dense vector dense representation like word to vec that you can use, that actually also understand the semantics of the word. But in this case, we are going to continue with TF-IDF, and we are going to see in the future video how this can be improved with word vector. Right now, what I'm doing is I'm getting all the feature names because I have given only the top 1,000 features. I'm giving all the feature names over here, and it will tell all the 1,000 features that are there. And if you select would call, would like, would receive, would take, these are all basically bigrams, because I have given like bigrams up to 2. In the test data frame, what I'm going to do is I'm going to take, now I have created from a train data frame, I have did a 80-20 split, so I have a test data frame as well. So I'm taking the complaints column over here, and then I am using the vectorizer I created on top and calling the transform, because my vectorizer has already learned from my training data. The only thing I have to do is I need to transform my test column. Right, and if you see over here on the top, what I did is I passed only the complaints column, that is the text column that I have over here, not the entire data frame. I just need to vectorize my text column, right? So that's what I have passed over here. Now similarly, it's going to transform my it's going to kind of transform my test data, and I will have the test vectors. Right, I can quickly print the shape while it is running. The next is I'm going to just print the shape of the vector to see how it is. And once this is done, what I'm going to do is I'm going to create a pandas data frame out of it. So in the pandas data frame, what I'm doing is I'm taking first the training data, first creating the training data frame. I am telling that take all the train vectors. The train vectors are nothing but the output of my train transform function, fit and transform function. I am creating 2 array. So I have 1,000 vectors now. Because my max features is 1,000, it's going to create 1,000 columns. And how to name the 1,000 columns? Because my 1,000 columns represent the 1,000 words, right? So in this case, what I'm going to do is I'm going to tell that vectorize tf.get feature name. Get feature name is this one, wrong, wrote, here, and all this stuff, right? So these are the 1,000 columns and the 1,000 feature name for the columns. And then what I'm going to do is I'm going to take the target column, which we use the dictionary and map function. And then I am assigning it, I'm concatenating with the train data frame. So my output will contain over here the 1,000 max features that we selected. and then the target column, right? The target column, I'm just keeping the target name. But in case if your word has a target, then you might have to keep a different name. Just remember that, because if your word is having a target, then this will get overwritten, right? So I'm going to keep that. So now if you see the top is run, now I have like 4 shape because that's what my column count is. And let me run the TrainDF that I created, which will have all the words as different columns and the target column. So if you see over here, this is how it is. These are all the different words that it creates. Sometimes the word does not make sense. The reason this word does not make sense is because we did stemming, right? So that's why some of the words are cut, because it goes to the root word. Now in this case, there's a account balance. Maybe we need to do some cleaning over here. The account does not make sense. Sometimes like you will have like a dot and people will put comma, but the tokenizer will remove the dots, right? So there may be some more cleaning required based on this, but we are going to continue with this model. And similarly, I'm going to do the same thing for the test data frame. Now I have my pipeline done. I have my data cleaning stop word done. I have my vectorizer done, right? So what I need to do is I need to run it through a model so that it can classify my target class, right? So this is how my test data frame looks. Now, how do I know which model works better? That's a big confusion, right? So what I'm going to do is for my model selection, I'm going to use H2O AutoML. And here what I have done is I have converted my 2 pandas data frame into an H2O data frame. So I'm telling H2O.H2O frame, it will just take the pandas data frame and convert into H2O data frame, and then I'm printing the data types of the train data frame. So why I'm printing the train data frame types is I need to make sure my target column that I am giving is an enumeration type. It should not be an integer type. If you give it as an integer type, what H2O AutoML will do is it will treat that particular variable as a regression variable, but ours is a classification variable, right? So let it run. In this case, like I just it is kind of converting the pandas data frame into H2O data frame, and once that is done, you can see the types getting printed. Now in this case, my target column, let me see if I'm able to see, because it will so basically I'm not able to see the target column because it has like kind of like masked to a top column, but the target column in this case is going to be integer by default because we are given 0, 1, 2, 3, 4. So what I'm telling is I'm just using it to create as factor. So that factor will just convert the target column into an enumeration object so that it understands it's by default a text classification problem. All right, now once the target is converted, what I'm going to do is I'm going to set my H2O AutoML pipeline. So let me kind of run the next 3 command and I will explain it to you. The AutoML is going to take some time to complete it. So here what I am doing is I am setting my H2O AutoML pipeline. I am telling my max models equal to 10. So run for max 10 models. If you don't give it, it will run for all the models that H2O AutoML supports. And it will take quite a good amount of time. But I'm just restricting in this case to run for like the top 10 models in this case, and I'm telling like my exclude the stacking ensemble algo. So I don't want to stack multiple models, so I'm just telling exclude stacking ensemble, and then I'm telling the just the n folds is equal to 0. I don't want to do a cross validation because I'm just selecting the baseline model here, right? I just want to know like which model fits better. I'm telling balance class is equal to true because it's an imbalanced data set. I'm setting it to true, but I will talk about imbalanced data set once I have the leaderboard model, how I can do it manually, right? And then I'm telling like the balance size should be 0.3, so the majority classes should be at least 30% is what I am telling, reduced by 30%. And I'm setting my x and y variable. I know my column name is nothing but the feature name is nothing but the words, so I'm getting the vectorizer tf.get feature name, that is my x variable, and y variable as target. I am starting the AutoML train method. I am passing the H2O data frame TrainDF as my training frame and the validation frame as H2O test DF just to validate it. And I am passing my X variable, that is all the words in the data frame, which is nothing but the vector representation, and then the y column. Now what it will do is it will start running the AutoML output. In this case, if you see, it's by default going to use the mean per class error as the sort metric, but you can override it with log loss or AUC or whatever you want to do. But I'm going to go with the default one. What it's going to do is it's going to kind of run multiple algorithms. The max model is 10. You can also give a time-based timeout. Say you want to run it for 50 minutes. You can just set 50 minutes, and after 50 minutes it will start. So first it has run for XGBoost, and it has given the mean class per error as 0.17. Now it's going to run other models. Say XGBoost 2, it has run 3, it is running, but the mean class has not changed because it did not find it better than the first model. It's going to run GBM, it's going to run random forest, it's going to run linear models, it's going to run everything and give us a leaderboard. Now what I'm going to do is, at this case, I'm going to just pause the video and come back after the training is done. So now basically our AutoML model is completed, and you can see it has run XGBoost model, it has run a GLM model, it has run a distributed random forest, it has run GBM. And since I limited to max model 10, it has only run this model. But if you increase it to 15 or 20, it may run deep learning models and other model as well. You can also use the exclude algos to kind of limit some algos. Say if you don't want GBM, you can say, okay, don't run GBM. If you don't want deep learning, you can say don't run deep learning, right? Now, this is good for in the hypothesis cycle. This may not give you a production ready model, but it at least gives you an intuition on which one to start your actual hypothesis with. And if you see like XGBoost model, first it has given the mean per class error as 0.17. And again, a different version of XGBoost model, it has given a 0.16 mean per class error. And after that, there is no improvement. So looks like XGBoost seems to be a better model. Because it was an imbalanced class, I set like balanced class and I gave 0.3. 0.3 is basically undersampling your majority class. If you give more than 1, it is upsampling your minority class. So let me check the leaderboard now quickly in the AutoML. And what we are going to do is we are going to pick that leader, and then we are going to iterate ourselves further and do better handling of imbalanced classes. So the leaderboard will show you what are the different top models and how they stand in the leaderboard. If you see the XGBoost 3, which we saw as the mean class per error 0.16 and log loss of 0.35, and you can basically maybe you can go and say I want to pick the top 2 models, or I want to pick XGBoost 3 and GBM and iterate further. So in the real world, maybe you want to go with the top 2 algos or top 2 modeling and see like as you tune your hyperparameter how it performs better. I can also predict on the text data set. So what I'm telling is I'm taking my AutoML.leaderboard and telling .predict and passing the test data frame. And in the next one, what I'm doing is I am just calculating the model performance. Right now, this predict will have all the predicted values which you can use. But if I just want to check the model performance, how it performs on my test data set, what is the metrics, then you can run this. If you see over here, this should show you the metrics. And in this case, basically if you see over here for each class, right, for 0 to, so we have like 6 classes, that is 0 to 5. It's showing you like how the predictions has been, right? So the error rate in the part 0 class, which is a majority class, is 0.08. But when it comes to the class number 5, right, the error rate is 0.36. The last row is the overall error rate, but this 0.36 and 0.21. The imbalanced class has not done great. The minority class has not done great. So let's see what we can do further better to tune it, right? Now what I'm going to also do is I'm going to check my hyperparameters used for the top leaderboard model. So I'm taking the AML leaderboard and taking I'm picking like kind of all the model IDs from that, and then I am telling that h2o.get model based on the model ID print the output. So if I run the next 2 steps, it will give all the hyperparameter that H2O uses. Now I need to convert that H2O hyperparameter to XGBoost actual model hyperparameter, right? So that's why there's a method called convert H2O XGBoost parameter to XGBoost parameter. So what H2O has done is it has taken all the default models and it has enhanced it with its own version. So that's what it has done over there. So once I print this particular output, it will show me what is the actual XGBoost parameters it used. so that I can take those parameters and I can run my own XGBoost model. So if you see over here, these are the parameters. The number of classes is 6, that is 0 to 5 label. It uses a multi-soft prob objective function, and it is doing like grow GPU is. I have a GPU in the backend, it's running GPU. If it is there was no GPU, it would have done CPU. It is doing like grow policy tips. So these are all the hyperparameters that were used in the model. Column sample by tree is 0.8, column sample by default it's 1. Right now, what I'm going to do is I'm going to take my own XGBoost model and run it, and then we are going to handle the imbalance classes. So I'm importing XGBoost. I am also importing like classification report and confusion matrix from xscaler metrics to see how our model is performing. Now, next time what I'm doing is I'm taking from the XGBoost, I'm taking the XGB classifier. I am telling run n estimators as 100, so it will build 100 trees in total. Right. So now if you want to have a higher number of trees, you can run it for higher number of trees and see how it is, or you can run a random search or grid search and see what works better. I'm telling the running rate is 0.05. The depth of each tree is 6. So each tree, it will build 100 tree, each tree with a depth of 6. I'm telling the same objective what we saw on the top. I'm just giving an kind of random state over here. And then I'm telling my updater, all right, has GPU. So I want to run this model in GPU. So what I'm doing is I'm telling my updater as GPU. And then what it says grow GPU, and then I'm going to kind of call the XGBoost classifier, and then I am fitting based on the training vectors that I created on the top. Right, before creating the pandas data frame, I have the train vectors, that is nothing but the fit transform of the TF IDF, and I am passing my target variable from the splitted training data frame target. That's what I'm doing. And then I'm going to run the predictions, and also I'm going to print the confusion matrix. So once this particular model is generated, what I'm going to calling is I'm calling that XGBoost classifier.predict. I'm passing the text vectors, right? That I'm training on the train vectors. I'm passing the text vectors, and then I am printing the confusion matrix to see how well our model has performed in this case. Right. So once this particular model is done, then I am printing the classification report. This is going to like take few minutes for the training to complete. I think the system in Colab is also slow today. So if you see, basically, these are all the parameters that were used and the predictions are done. If you see the classification report, again, if you see the confusion matrix, the top classes have done very well, like 15921 is right. The diagonal part in the confusion matrix is the right values. Remaining are basically your false positives or false negatives. Right. So the top one has done better. The second one has also done better. But if you see the imbalance classes, like last one, if you see out of 1330, basically, let me run the next step. And then let me talk about it. If you see that the bottom class 1330, basically 464 plus 210 plus 107, almost like 50-60% error is there, and even in the before class it is the same way, right? So you can see in the classification report as well, basically the overall recall of the top one is 91, 85, 89, 90, and it's only 61, 78 in the bottom one. So how can we make this better? How can we instruct the XGBoost model to handle imbalance classes? So for that, what I'm going to do is I'm going to add an additional parameter per row. So I'm going to assign a weight in each and every row. If I have 10,000 rows, each row will carry a weight matrix. Right, that's what I'm going to do. And for that, I'm using sklearn utils.import class weight. I am telling like compute the class weight based on the training data set, the target variable, and I'm passing all the training dataset target variable. So it's going to go and check the distribution of target variable, how it is. And based on that, it's going to go and compute class weight. That's what here I'm going to print the class weight. So it's going to say like, okay, this is a majority classes, this is a minority classes. In the minority classes, what it's going to do is it's going to assign higher weights for each row. In the majority classes, it's going to assign lower weights for each row. right? So these two are running, and after that I will have weights when I complete this step. If you see, basically the 0, 1, 2, which are majority classes, have lower weights compared to the last two classes which has higher weights. So basically this weights, what I'm further going to do is I'm going to create the weights in the same size of training matrix. So my training, because for each training instance I need to pass this weight, right? So it needs to be in the same size of train matrix, and then I am printing the weights, and then I'm iterating to the train matrix nest, and then what I'm doing is I am assigning the weight vector per class. So by default, it will create all the ones in the weights matrix. I'm going to iterate this particular train matrix which has ones, and then go to my class weights I created on the top, and then assign it to the weight matrix. So in this case, if the target is going to be 0, it's going to have, and target is going to be a majority class, it's going to have lower weights. And if the target is going to have like a minority class, it's going to provide higher weights. Now, once I am done that, I am again initializing my XCBoost classifier variable. I'm just going through the steps while the top is running. The reason is I think Colab environment that I'm using is pretty slow. So I just want to proceed while it runs in the background, right? Next, what I'm doing is, if you see here, it has assigned all the weight metrics, and it's going to be the size of the training data frame. I am again initializing my XCBoost classifier. Let me run the next two steps. All right. So what I'm doing is again initializing my XCBoost classifier. I'm passing the same set of parameters, n estimators, max depth, and all. And here, this is where it changes, right? In the XCBoost classifier.fit, I am passing the training matrix. I am passing the training target. I am also passing sample weights. These are the weights I created on the top for each class, right? So the sample weights will basically go and assign each training instance weight, and the XCBoost model is going to train based on that. Forget the warning, it has completed the training. Now I'm going to use that to predict the output and see how well it performed on the minority class. So let me run the prediction, let me run the confusion matrix, and also the classification report all together. I have commented out a section over here. If you want to just score and see how it is, you can use the XCBoost classifier.score method, and that will give you the accuracy. But since it's an imbalanced class, accuracy might not be an right metric, right? I want to look at either precision or recall based on what I'm trying to solve. So now let me go and check how the final classification report and how the confusion matrix looks like once this run completes. Now, in the top, you saw the bottom two classes were basically pretty badly hit and classified. Basically, it was like, I think 61%. Let me go on the top and see how it performed. It was like 61% recall and 78% recall, and only 1330 instance in this case was rightly classified, and 1834. So let me go and check like how it has performed. Now, if you see over here, from 1330, it has become 1704. And if you see, the false negatives and false positives are basically lesser now. And similarly, on the top to 2024 also, you can see from 1800 it has classified 2024 accurately, right? And if you see even the recall report, it has come from 69 and 71 to 78 and 86, but the top classes have impacted. It has come from 91 to 86, but that's fine, right? That's what I want. I want to balance my prediction. I don't want always my majority class to be predicted. So I may have taken some hit on the recall of the other classes, but at the same time, my prediction is close to it. I can still fine tune it better and make it better, which I will maybe cover in a later video, or you can try it as kind of an exercise that you want to take back. But that's about it. Maybe I want to go and convert the sparse vector into a dense vector and try it out. Maybe that's what I'm going to cover in the future video. Thank you very much.